Hello and welcome back to the development of the Feersum Scheme compiler. Right, in the last episode we had a look at the lowering of captures, so when a lambda references a variable outside its own environment. We went through in the binder and bound those references to captured values as a special symbol reference to a captured symbol, and so that means that the binder now produces a syntax tree with enough metadata on it that hopefully we can lower those as classes and read and write from fields inside the class. So I'll start by going over what we did last time. It was mostly in the binder. So the binder used to have this try find binding, which it doesn't need to be recursive anymore. We used to have this try find binding which would try and look it up in the current scope, and what we've done is added this parent lookup. So parent lookup is a new method that's mutually recursive with the lookup and capture. And what these two methods do is they will either, if we have a parent scope, so if we could look further up in the source tree, we will try and capture a value from outside the current lambda. And if we did capture something, we return a captured reference to it. And in the lookup and capture, we just try and find it in the current scope, which is in this case going to be the parent. And if we do find it and it's something that needs to be captured, like a local or an argument, we will wrap it in this environment storage type and return that. So the idea is that with this we'll end up with, as well as storage references for variables like locals, globals, arguments, we've got this environment storage type which tells us that the value is stored at a given index into the environment, and it tells us where it was captured from, and we have this captured which tells us that it's in the parent environment. And we can chain these captures, so we can say, rather than it just being captured from an environment, which would be a lambda that reads a value out of the parent environment, we could say it's a captured or captured from some environment. So we can provide the chain to be able to walk up the scope tree. And right at the end of the last stream, we did some work in the compiler for hoisting the captured values. So when we emit a lambda, this is where you have a lambda in your code. You'd expect that lambda to be something that you can pass around as a value. So what emit lambda does is compiles the code of the body into a method, and then it does emit method to func. So this basically takes that method reference and turns it into a system.func. What we added in was this hoisted list, and we do a fold of this hoist effectively, which will say if there is, for each captured thing, so everything this lambda captures, we go through and make sure that we've already moved that into the environment if it's something that's from captured directly from the environment around it, which is done by just reading from the original location where it was captured from and writing it back into the capture. But this read from and write to don't actually work yet because we don't have the environment types. So the plan for today's stream is to go through and add support for environments. So the way the environments are going to work, because we're compiling this to .NET IL, an environment is going to be an instance of a class, and the methods that at the moment, all our methods are, whenever you write a function in Lisp, let's see, like the factorial here is a static method on some program type. So with the adding of environments, what we will do is we'll make some of these methods instance methods on the environment rather than static methods. And that way they'll be able to see the environment and they'll be able to read and write from it by reading and writing as if they were reading and writing instance variables. So where we're going to start here is in the compiler, I think. So at the moment in the compiler we have a add core decals. So this basically at the moment creates just a single type which we use for our cons pairs. So what we're going to do is add in another type for the environment. So the plan here is that the environment would be a class which has a pointer to the parent environment, so it's going to create a linked list at runtime of environment so that we can walk back up that chain. If we've got a capture that references a capture, we can look at the parent environment and the actual storage locations for all of our variables, which is just going to be an array of object. So the environment type is going to be a new type definition. We'll put it in the compiler services namespace because why not? And we might as well just call it environment. And it's going to be a class, and it's going to be public, and we want this ANSI class attribute as well. I'm not 100% sure why we need that, but best keep it the same. We're just going to inherit directly from the object again. Good. So we've now got the environment type definition. We'll have to add some fields to this, but the first thing we probably want, we'll create the fields first. So the first field is going to be parent, I guess, which is going to be a field definition. Can I do name of in F#? No, it doesn't look like it. Fields public, and it's going to be of type environment type, and then we're going to have an array which is going to be our actual slots, so we'll just call it slots. Now this isn't very idiomatic C# or anything because we have two public fields on it, but it will make writing the bytecode and stuff a lot easier. Actually, I'm not sure if we will ever actually need to, these might not need to be public, but best to make them public now and then change it later if we don't need it. And these are going to be it's going to be an array type of objects. Just copy and paste that. Living in the 21st century. Good. And I will add those two fields to the environment. Parent and env fields, add slots. So now we've got those two fields, we can define a constructor for the environment. So the constructor for the environment will take a pointer to, well, take a reference to the parent environment. So we'll do env methods. So we're going to create a constructor in this assembly, and we'll need to do some stuff to build up our IL. We'll add a parameter definition for our parent environment, which is going to be env here. And what we will do is we'll emit an opcode. Going to load the first argument, that's this parameter. So what we're going to do here is store this the argument for the parent environment as in that parent field, which is ctor il emit. Load argument 1. Store it in field parent. Good. And that's it, I think, for the environment type constructor. And then at the moment we're in add core decals, we're just returning this type definition for the constructor type. But what I think we want is a kind of like core types, which is where we'll store all of these. That should probably be a 3/ comment. So these are the like type definitions for things that the compiler is going to emit calls to at runtime. So we've got the cons pair, which it uses when it's creating argument lists and things like that. And these are kind of logically distinct from the built-ins. So the built-ins are kind of methods that are made available to the scheme code that you might write, whereas the core types are going to be things which the compiler wants to use. So we're going to have const, which is a type definition, and we'll have env, which is also a type definition. Good. What is this unhappy about? But it kind of is matched, that's the shame. Oh yeah, that doesn't want to be S, that wants to be a semicolon. I always trip up on lists in F#. So core types. I could just call it core. And then anywhere where we reference the cons type, we need to go core. And down here, when we create it, and we will make this. We'll make the return type no, that must be an equals. Good. That looks a little bit more like it's maybe going to compile. So the idea is that we've now got add core decals returning two different types. We've not actually done anything fancy in the environment yet, but let's see if it builds. It does build. So we've got our environment type in the compiler. Oh, we've got that. Let rec change. And we've got the environment type. I'm just going to check this in so we can move on fearlessly. So this at least works the same way that the old code used to. Adds a core decal to that. Good. So now we've got the environment type. We can change it so that references to the environment read and write from that environment. If we're reading, yeah, so how do we want to model this? So if we go back and have a look at the, I don't know, this is an example which actually needs to use an environment. So our old factorial can just be a plain old static method because all it ever looks at is this n and then it calls factorial. For the iterative factorial, this call here to iterfact with accumulator needs to look up this lambda from inside the environment of iterfact, not the root environment. So it needs to capture it. So what we could have is that itifact with accumulator is an instance method on the environment of itifact, which I think is the way that we do it. So that means that every time we read and write from the environment of the parent, we'd be reading and writing from whatever the this pointer is, the this reference. Whenever we want to read and write from our environment, we'd have to store that as a local and read and write from that. I'm not sure if that's going to be the most simple way, because the other way is that we could say that anytime we're reading and writing from our environment, we're reading and writing from this. Anytime we're reading and writing from the parent, we would look further up. That might be the easier way of doing it. So we can now assume that this is an instance method. This is going to get tricky. So at the moment, when we read and write from an argument, we're given the argument's index, and we do a store to that index. If it's an instance method, if this was a standard static method, if write2 was a static method, then that would be argument 0 and that would be argument 1. But if it was an instance method, then this would be argument 1, this would be argument 2, and this pointer would actually be argument 0. So we need to know whether or not all of our methods are going to be instance methods. Or at least when the method is being compiled, we need to know whether or not it's going to need a this pointer, because we're going to have to increment the index for the argument if it is. Part of me is thinking that the simplest way around that is to just always have instance methods, but static method dispatch should be a lot faster, and lots of our code won't actually need instance methods. So we can have something. Is there anything on the emit context that's going to tell us? So hoist is the things that we've already moved into the environment. When we lower a lambda, we create a new context. So what do we have? We've got the locals. We've got the list of captures for the current lambda. And we call emit named lambda. We don't pass the captures in. I start off by hoisting nothing. I could just have like a has captured flag. I think we'll pass the whole lot of captures down, because I think what's going to happen here is that we're going to want to know how many things have been captured. So then going through and adding all those parameters. And somewhere down here we create So what I think we're going to do is we're going to count how many things are directly captured by this lambda. This isn't right. So if we've got the list of things that are captured by this, we need to know how many things are captured by out of this lambda's context if we're going to make it as an instance method on this environment. Yeah, it's awkward. So we kind of when we call this emit method to func, we're going to want to create an instance of an environment, rather than at the moment we've got the method we call load null. What we need to do is create an instance in the environment. Method will have to be an instance method. Well, how bad would it be if everything was an instance method? What I'm going to do is I'm going to have a look at what the compiler is generating for. I'm just going to have a look at what I've changed, which I don't think is anything interesting. It isn't. I'm just going to revert all that. And then have a look at what the compiler is generating for some kind of like example code. Because I'm interested in finding out when we come to emit lambda, what information we've got, so that we know, what we've got in terms of information to be able to create this environment. So define a it doesn't like that. So define a, let's define B, define C is going to be another lambda which just returns B, and we call C. Okay. So we have our first context is the script body, which has no captures, which is what we'd expect. Our second context is the lambda, so that's going to be A. And that has one capture, and the capture is local 0. Okay, so I think this might mean we have the right amount of information. So hopefully I should be able to F5 again. Okay, right, that's not it then. So that must mean this first thing that we see is lambda A. So the problem we have is that in our current syntax tree, we don't have quite enough information about the lambda. So let's go have a look and see if we can put that in from the binder. So in the binder, when we do a lambda, we've got the number of captures, no, the actual captures themselves. But do we have enough information for to be able to know how many slots we should allocate in this lambda's environment? So the problem I've got right here is that when we call emit lambda, we want to be able to create an instance of something here with a given number of slots that matches the number of things that we're going to hoist into the bar here on line 203. It matches the amount of slots we're going to hoist things into. So we'd want to be able to make sure that the current environment has the current lambda that this nested one is in and is about to be stored into the environment of, or called from, or whatever, has got enough space in its environment to move all the captures into. So we know for each lambda how many things it captures from the outer environment, but for the environment where things were captured from, we don't keep track of that by the looks of things. So the captures list is mutated here. So if you find something, if we call lookup and capture and we found something that was captured, we add it to our capture list. What we kind of want to do here is when we capture something from a given environment, would that even be enough? Because you'd need to know maybe we just need to kind of walk that maybe we just need to count the number of slots we need in our environment. So if anyone references get the environment size for the for this current body, I guess. So what kinds of things we've got? Let's just do this is not the greatest in terms of efficiency, but maybe it'll work. So we've got null, numbers, all the rest of that. This kind of feels wrong to go. I mean, we know here when we capture something. So let's keep track of the environment size on our binder context as well. So this is going to be an int, but it's going to be an optional int. So when we create a new binder context, we always start out with an empty environment. And then when we capture something, we will create the captured storage for it, store it back into the scope, and say the That's just everything that's in the scope. No, we'll carry on doing this. So the environment size equals we'll just increment the environment size. So if there is nothing yet, we will return someone otherwise. So the reason why this is an optional int is because we want to be able to keep track of like some 0 or something, as meaning we don't actually store anything in this environment, but someone does reference something from this environment. So if we look it up from the parent, we add it to our captures. So here, when we perform the parent lookup, we want to say I'm going to mark that the environment's actually being used. And this is actually something like option dot default value no. Nah, let's just leave it as it was with the function, at least I think that's probably going to be simpler to understand. So this is for those. Yeah, sorry. The target for this compiler is .NET IL. So we're emitting .NET bytecode at the moment to an in-memory assembly, or if you run it as a batch compiler to a DLL on disk. Yeah, so we mark the environment as used, and now we've got the environment size. When we make the lambda, we can do lambda context dot env size, which is going to be all the way up here. So that's our captures. Int option is that environment size, and then in compile we call CC is an interesting question. I'm kind of putting it off so far, not in terms of doing it, but in terms of making a decision. So I've not seen any good solution so far for .NET for actually implementing call CC. I think the closest like simple solution is to model it as throwing exceptions, catching exceptions, and returning that value. And it works for most of the ways that people use call CC. But it's tricky to implement the full thing. Yeah, or you actually implement it the way it's supposed to be implemented for Scheme, which is, yeah, linked list of stacks, and you move all of your context onto the stack. We could implement that with like a tasks-based approach in C#, but the problem with tasks is that everything has to be async, and everything would have to be a task. Everything would have to return tasks to be able to thread that environment, and you are effectively moving the entire call stack onto the heap. But yeah, stack copies I don't think are going to be an option because it's a managed runtime. But throwing an exception and catching it works kind of okay. Yeah. But it's still an open question for this, whether or not I properly implement call CC. I imagine not. Or at least not perfectly to spec. Okay. Where was I? Yeah, exceptions aren't perfect. I was wondering whether or not you could get away with some kind of like half and half approach where you use exceptions for the cases where call CC, where the continuation is only ever called from inside the block, which is where it would work from, and then some kind of task-based model outside that. You could probably go kind of half and half and have like blocking tasks and kind of like effectively fire off a coroutine. When the continuation hasn't been called. But without turning the whole call stack async, you probably have to block, which isn't ideal. It would be an analysis nightmare. Yeah. The other one approach is it lambda lifting or something, where you effectively turn everything inside out, but none of it's very easy to map onto like the way that the .NET runtime works, the way that stack-based languages work. So we have the environment size. Nope. Yeah, and if you've got the captures as a parameter, you're still doing the linked list of captures thing. It's just going to be 0, 0. Right, and then when we call emit named lambda, we've got the environment size. So when we create the context, we can do copy it in there. In the emit context, we can have the emit context is going to be I'm not 100% sure whether or not what I'm doing here is really lambda lifting in terms of just making lambdas instance methods on the environment. But if you think about it, the environment is just the this reference, so it's kind of there. But the thing is that not all of the environment will be moved onto the stack, I don't think. Right. Env size none. Then when we call emit named lambda, don't need to do anything there. It's when we read and write from the parameters. What's it called? Read from? Yeah. So read from, if we've got an argument, we want to say something like that. And when we write to an argument, we want to do the same thing, and then we'll just have so if we have stuff in our environment, we'll have a this parameter. So reads and writes from the argument need to be incremented. And then the flip side of this is when we do emit named lambda, we define a method we need to decide if it's a can we add more flags here? So if we have stuff in the environment, we would so if we've got methods, so if we've captured stuff in our environment, then we emit, we add the method to the environment type, otherwise we add it to the program type. If we're going to add it to the program type, we need to do method decal dot. What are those things? Attributes. Maybe. Gonna have to assign it back to itself. And the same thing with if it is an instance method, we'll make it I don't think it needs to be virtual or anything like that. I think that might actually be all we need to do. See whether or not that works. No, there's one more thing we need to do in the compiler. We need to actually create the instance where we do method to emit named lambda. Yeah, method to func. So that's going to be, we don't want that to be load null. You've got your own scheme implementation. That's cool. Yeah, there's lots of kind of like halfways between interpreters and compilers, and some interpreters you do compilation and then interpret values, and depending on exactly how you model scheme, even if you're compiling it, you're still only compiling it down to some like optimized interpreter for some kind of nominal machine rather than, yeah, it all gets a bit fuzzy. So method to func, can we just, where do we call this from? We call it when someone references a built-in. And we call it to turn our lambdas into a func. So here, what I kind of want is method to func is just going to do emit method to instance func, but it's going to have loaded null onto the stack. With the context so we can still do the same thing for the built-ins, and down here what we'll do is we will say if we'll match the M size. If there is something to allocate, we will do create environment and emit method to instance func. If there wasn't a size, we'll just do the standard emit method to func. So now we need create environment. Which is actually going to take a context and a size. Because we need the context to know where the environment type is. And we will do So this is going to be the outer environment. Not the lambdas. It's going to be the limit context for the outer environment. So we can say if the context has an environment, then we'll do we'll load this. Otherwise we'll load null, because what we're going to do here is we need to deal with the case where we need to create the first environment in the stack. So if we aren't currently in a lambda with a dynamic environment, then we'll just use null. If we have a dynamic environment, we load that. Then we call get so we get the constructor. What's going wrong here? I like seek dot first, I think. And now we need to call the constructor. So we get, it should create an instance of our environment. Let's see if it works. Still not going to read or write from that environment yet, but So we're emitting a lambda. The environment size is 1. That's good. It's calling emit named lambda. It's moving the things that lambda captured into our environment, then creating an environment instance for the lambda. And then this is the inner one. The environment size here should be 0. It is. The captured size should be 1. It is. And that throws an exception. Fair enough. We need to call import reference, I think. So that's going to be I'm not sure if it's the constructor itself or the environment type that it's unhappy about. Let's go copy what I just wrote. Should make things a little bit easier. Still getting an exception. Object reference not set to an instance of an object. Import scope. Sounds like it's struggling with that import reference. Let's put a breakpoint in create environment. And rerun it. The environment is sum of 1. Interesting. So we're emitting the first lambda that we're going to emit is going to be the inner lambda, because we recurse down to that. Because that's the first one we finish emitting the body from. The thing is, why? Why has that decided that it needs to create an environment? Because the size is 0. So I think this is like in this piece of code here, this lambda here, define C, which returns B, shouldn't need, oh no, it does need an environment, because it needs to be able to look up the parent environment. That is correct. So why are we, so it's loading the parent. Let's try getting those constructors. What is going wrong here? Let's have a look at where we create the cons pair. We do that. Yeah, it does seek.head. Calls new obj. I know what's happening. I think we're forgetting to add the type to the module. Yep, we don't actually do main module. So now our environment is part of the module. We should be able to just call a constructor in create environment. We don't need to do this import reference because it's part of the same module. We can also do that because it's a little bit nicer. Let's try that. Going to optimistically go for it. Right, the signature is incorrect. Wow. That's interesting. What signature is incorrect? I'm assuming it means the type signature. In here. So let's just try running that again and see what happens. No. So it's main method invoke. This is probably because main method is going to end up being an instance method somehow or other. Why is it the signature on the assembly and it can't even load the assembly? Well, let's try compiling something from the command line. And then we can look at the IL. So if we do .NET run and then do spec to effect. For spec to effect.exe. So this is the IL for the it effect example. So we've got It's going to be the thunks, isn't it? So for every method, like the script body, the lambda 1, lambda 2, we also emit these thunks which do the argument checking and then actually call the main method. The problem here is we're doing a tail call to an instance method. So the first thing I'm going to do is get rid of the tail calls. And the second thing I think we need to do is make the calls to the thunks our own program. We may make the thunks the same. So make them static only if they're calling a static. So we've got so instead of doing that, we want to do thunk decal. Okay, and we'll just comment out the tail call for the time being, because don't know if it's making things better or worse. So, do I still have something interesting? This is, I pasted a blank line, I think. Signature is incorrect. Signature is just always incorrect. Let's recompile that itafact example and see what ILSpy has to say about it. So now the script body is a static method. Still calling an instance method for script body though. I wonder if we need to just we'll just abstract out the method attributes. And the attributes will be either public or public and static. So I'm wondering whether or not the flags that you pass into the constructor changes how that method definition behaves. And it's just always emitting an instance method call to it. Because it looks like the attributes on the method are actually correct. Yeah, alright, okay. So we'll make B return whatever A was given and then call B. That's promising. Let's compile itafact again. That's not. It's not going quite as well as I was hoping for. Value cannot be null. Parameter name parameter. Read from. So I think the problem that's happening here is something to do with the arg index. It's calling emit with an int 32. we just always return that, that's going to be wrong, I think, but shouldn't crash. Oh no. So lambda 1 in this case should be the main. We've got the script body, got lambda 1, we're missing lambda 1's thunk. Yes. So all the methods that use an environment are instance methods on the environment, which is up at the top now. So lambda 1 thunk. That's not right. I think this was correct. We do want to offset our indices if we're dealing with, if the current context has an environment, because that means that it should be an instance method. But the bit down where we do emit named lambda, we check the current environment, but really what we should be doing there is checking the environment size of the lambda that we are about to emit. Right, now let's see whether or not we can write some. So if you define A, which is just another lambda B, which returns the parameter to A, and what does it do? It compiles to something. If we actually try and call that with something, yes. We have a lambda, it returns another lambda. Which returns the arguments to A. And we just try and call that with an argument. Runtime detected an invalid program. So let's go see what that compiles to. Path cannot be the empty string or all white space. Interesting. Path needs to have a directory in it for some reason. Okay. Let's have a look at the IL that's in that test executable. So we've got a main method at the bottom. We've got the body and the body thumb. We've got all of the arithmetic operations, and then up here we should have, we've got the cons pair, we've got the environment. The environment has a constructor and it has lambda 0, which is an instance method. It has lambda 0, which is the inner lambda. So lambda 0 calls load arg 1. What did it? Doesn't really make much sense. So the program oh, I see. I think that load arg 1 and nop is supposed to be hoisting A into the environment. So I think we're not compiling that bit correctly. So if we have already hoisted it, we don't hoist it. If we haven't, we call read from and write to. Read from turns built-in into a method. Loads null and for the captures. So it's going to call load arg, then store. It's going to call store lock. I think those want to be pops to just make this compile at least and be accepted by the runtime. Get our test script again. Still an invalid program. Let's go find out what's going wrong. Let's compile it. And let's have a look at the IL. Okay, so we've got lambda 0, lambda 0, 0. So these are the two methods. That one looks fine. So the inner lambda just calls load null, which is where it would have been reading from the environment, and then calls return. can't see anything obviously broken with that. The inner one's thunk calls load len, throws if it's not 0, and then calls. Yes. Where the thunk calls the instance method, we need to load the instance onto the stack. So if we've got an instance method, made the thunk, so when we call emit named lambda, in the other place, we oh no, it's inside emit name lambda, where the thunk makes the call to the method declaration that the problem is. So we've got the body, and then inside the thunk we call this unpack stuff, and then we say if we have an environment, then and then what is parameters here? It's a collection of parameter definitions. What I am going to do is replace load arg0 with something like hopefully that will map onto either 0 or 1 depending on whether or not it's an instance method or not. Unpack remainder, raise our count mismatch, and that's where we actually do want to reference argument 0. Right. Continued optimism. test lambda. So we called that and we got back a procedure. So let's call the procedure and hopefully we'll get 1, 2, 3. No, we got null because it loaded null from the environment. Still, that is a lot more working than just throwing an exception because the program is invalid. So now we have what have we done? And still not 100% happy about the way that we've got a whole bunch of code now, which is conditional on environment size. So I might have a refactor in the future so that we don't have that argument index stuff and instead we actually get it out of the parameters array for the current method that's being compiled, but we'll see how that goes. So if we are referencing an environment directly, what I'm going to do is I'm going to take a look through what the changes are and commit them so that we've got some reference. So we've got the new environment size on the binder. Yeah, I mean, I think we can calculate the environment size here based on the captures, but I think it's fine to do it that way. Because we know the environment size is basically every time we have captured something or a plus every direct reference to the environment in our current thing. It's just everything in here and then some if there's a captured thing, some 0. The environment size for the emit context, yep, environment size. Create instance methods on if an good. So now we've got that all checked in. Load, we want to make that read from and write to. In these two cases, we need to read from the environment. So I think the simplest one to do is reading from the environment directly. So what we're going to want to do is we're going to load arg0, which is going to be the environment. Gonna load, let's load field A. Okay, we'll get the documentation up. Let's load field address. Not what we want. We want load fields for the environments. Second field. Just gonna wing it like that for the time being and rely on the order that we added them. So we load that array, which is all the slots, and then we will do store index ref and at the index for loading from the environment. It's basically going to be load index. Should be simple enough, and we can test that by capturing a variable and then using it afterwards from the same lambda. Because once we've captured something, we have to move it into the environment, and then even the same lambda has to read and write from that environment structure rather than where it was expecting to. So if we say lambda, which takes no parameters, we'll define A as being 100. We'll have a new lambda which just returns A, so that's captured it, and then we return A ourselves. This should evaluate to 100. Okay, it's not happy. Write to create. Values are the wrong way around on the stack, I think. No? No, this is... One, 5, 1. Store element. So we store element reference, and this is load element. We can use the same example again. Still fails. I'm 151 again. So when we do a store element before, we've got, yeah, so you've got the value, which is the array, then the index, then the thing you want to store. So what we need to do whenever we write to the environment is we need a variable, and we'll have to store it into that temp variable. Context. We've got .il dot body dot variables. Add Visual Studio Code has given up. So we create a new temp variable, we'll store it into that temp variable. And then we will load this parameter, load the array out of it, load the index, which is a constant. Then we'll load back our temp value. Doing this in the wrong one. This is for the store element. So we make a copy of it in the temporary variable, load this, load the array of slots out of that, load the index in there where we want to store it, load the value back again and call store element. And then to actually do the load, we would load 0, load the array of indices, load the index, and then call load element ref. Let's go find that temp test scheme. And we'll rewrite our lambda here, which is lambda. So no parameters defined as 100, defined B as something that captured A, and then just returned A, and we called it script body lambda 0. We don't currently create the array of slots. So in create environment, we give it the size. So let's do never seem to be able to write opcodes with the correct casing. We will load the size. Then Oh no. Size isn't an int here. Size is oh no, size isn't it? Okay. We're all good, but it might be 0. Then in the constructor for add core decals. So in the constructor for the environment, we will want to initialize our slots as well. So let's add a parameter. This one's going to be an integer. Oh, just a standard int 32, and we will we've stored the parent pointer. We'll load arg2, which is going to be the size. Then we want to do a new array, which I think we give a, see what we do elsewhere. So you emit the size and then you call new array. Like that. So we've loaded the size from the stack, that's from the parameters. And that's just object, and then we store it into the slots field. Hopefully we should get slightly less null reference exception this time around. Always a good thing. Okay. I think I'm still pasting the empty string for some reason. We get 100. That's good. What about this lambda? I can't remember what this one was supposed to do anymore. That's throwing null reference exception. Because it's a lambda that returns a lambda. It returns the captured value. I'm not sure why that would throw null reference exception. It's doing it in lambda 0, so in the first lambda, which means so loading the arguments array. Let's have a look at what it generates. So we've got our two instance methods on the environment, hopefully somewhere. Here we go. Lambda 0, 0, lambda 0. So the constructor looks correct. We create an array of objects and store it in the slots. Lambda 0, which is where we're getting the null reference exception. Let's have a look at what the test was. It's going to load our 1. Store it in our local 0. So this is the temp switching thing. Load arg 0. Load field slots. That's good so far. Loads index 0. Loads the local back and stores it into the slots. Then it loads the environment, loads index 0. Loads the environment size of 0 and calls the constructor. So this is creating the nested environment for this lambda. Loads the function for that lambda, creates a system func instance for that. It's very interesting. Why would that be throwing? So the way it could be, it's not going to throw for this load function. I don't think it would throw for the new obj either, unless they threw, but we would see the exception from inside there rather than where we see it right now. So I kind of feel like it's either this load field or the store element. The thing is that lambda 1 is going to be this, and lambda 2 is going to be the lambda 0, lambda 1. So lambda 1 is going to do something similar. So it creates that, stores it, pops it, and loads 0, loads the field. So something subtly different between those two. That's getting it. This is getting. Interesting. Don't know, because the IL is very similar between those two methods. So, and it was throwing from inside the body of the lambda. Let's just run it again and make sure. So that throws inside lambda 0. Why? So if you just make that lambda and then still return 1, 2, 3, it's upset. So it's something about the lambda that captures the value. Do we need to call it to make it through? We do. So we call it with anything. Interesting. That crashed in an even more spectacular way. DBG's crashed. Something went wrong with that last debugging. So how about that returns the procedure that returns 123. Yeah, which is this in 123 here. So if we make this, if we do something like define B A, we're still good. What happens if then we try and capture the local B instead? Yep. So it's something about copying that value into the environment. But how about if we have a lambda that you don't give it anything, and we do define A. So that works. I know it's returning null there, well, the empty list, but that's because we can't read out of captured environments yet. But it doesn't throw an exception when it's making the environment. So there's something about capturing or reading from the arguments. It's going to be to do with indices again, I think. So let's try and compile and run this from the command line, because I'm wondering whether or not this is something special because of the subtle difference between the way that we run it in the REPL versus the way that we run it when we actually compile it. I doubt it. We'll run the compiler and we will do test that. Oh yes, it needs to be /. What is going on there? That is a bug. And then do get a null reference exception. Can we see more information about it? Let's go to the launch tasks and see. We've got test example, stop at entry, and let's do just my code. False, because we don't have debugger stuff for this. And we should. And that is going to be /test.exe. Ah, yes. The output we do something somewhere to put exe on the end of this output, but I imagine it must be somewhere in here. Yeah. So this needs to be DLL for reasons I don't understand. So if you run the compiler again, we should end up with a test.dll as well as test.exe. Do, and now we should be able to run the debugger with test.dll. Null reference exception, can't open or find a PDB file. That's okay, we haven't got PDB files. Error processing variables, great. What information do we have? Initial error in the C# compiler. Let's try and single step. Nope. Well, it worked at least a little bit. So can you view the disassembly? Well, there's a disassembly window. So if we capture from something to do with the way that we capture from that argument. So notice in lambda 0. Script body lambda 0. So that does load arg store local 0. Load field load constants, load local again, and store element. Whereas the lambda 1 does just a box and store local. That's an instance method. I don't know. Let's have a look at what we've got. Current state, though. What have we actually done? So I'm feeling like it's probably one of those problems which we can come back to. So create environment. We now allocate an environment with the correct size. And when we store and load to the environment, we at least try to read and write from that array of slots. And when we've captured a is it to do with loading? No, because we do the arg index stuff. When we've captured an argument, it doesn't seem to work, but I'll have a look into that later. And the environment now takes the size as another parameter. Right. And this should be create Okay, I think I'm going to leave it there. So thanks for watching, and what we've gone over today then is we've started to emit reads and writes to the environment. We've created our environment type, we've converted methods that reference captured values to instance methods on the environment, and we're just starting to convert reads and writes to be loads and stores from the environment slots array rather than loads and stores to the actual arguments or locals themselves. So next time we will work out what went wrong, unless I find it out before, and we will work on reading and writing from captured environments, which means walking up the chain of captured environments and then doing a load or store from wherever we ended up. So thanks for watching, and see you next time.